A Markov pump describes a system that jumps among possible states, with each jump having a probability and with some directions favored over their reverse directions. The main idea is that a small one-way advantage on every chosen forward edge creates a positive net flow, and that positive flow makes a quantity increase over time. The explanation begins with the meaning of a Markov chain and then follows how bias transitions, accumulated flow, and phase reset work together. A Markov chain is a model in which a system sits in one state at a time and moves to its next state using fixed transition probabilities. In this theorem, the transition probabilities may change smoothly with time, but at each time they still form a valid probability rule because the probabilities in each row add to 1. The chain is also assumed to be irreducible and aperiodic, which means every state can eventually reach every other state, and the motion is not trapped in a repeating time pattern. These conditions guarantee a stationary distribution, which is a stable set of long-run state probabilities that stays the same after one transition step. The stationary probability of state I is called pi I of t, and it is positive for every state, so no state is ignored by the long-run behavior of the chain. For each selected forward edge from state I to state j, the reverse transition from j to I is weakened by a factor called e to the negative lambda times aij of t. Because lambda and aij of t are positive, this weakening factor is between 0 and 1, so the reverse jump is smaller than the matching forward jump before the state probabilities are compared. The theorem also assumes that pi I of t is greater than pi j of t times that same weakening factor, which makes the forward-weighted flow larger than the backward-weighted flow on that edge. The probability current on one edge is the forward-weighted flow minus the backward-weighted flow, written in words as pi I of t times kij of t minus pi j of t times kji of t. Using the reverse edge rule, the backward part becomes pj of t times kij of t times e to the negative lambda times aij of t. Both terms now contain kij of t, so the edge current factors into kij of t times the difference between pi I of t and pi j of t times e to the negative lambda times aij of t. The transition probability, kij of t, is positive, and the difference in parentheses is positive by assumption, so the current on every selected forward edge is positive. The total current j of t is the sum of all these edge currents over the selected forward edges. Since the selected forward edge set is not empty and every included edge contributes a positive amount, the total current j of t is positive at every time in the interval. This also shows that detailed balance fails, because detailed balance would require the weighted flow from I to j to exactly equal the weighted flow from j to I on each matching pair. The scalar quantity b changes according to the rule that the derivative of b with respect to time equals j of t. A derivative gives the instantaneous rate of change, so a positive j of t means b is increasing at every moment in the interval. The total change in b from the start time to the end time is the definite integral of j of t over that interval. A definite integral adds up all the tiny changes across time, and because j of t is continuous and always positive while the interval has positive length, that integral is strictly positive. Therefore, b at the end time is greater than b at the start time, so the pump produces a real forward increase rather than canceling itself out. The theorem also tracks a phase angle called theta, which updates step by adding an amount called omega k. Modular arithmetic for angles treats two angles as the same when they differ by a whole number of full turns, so being congruent modulo 2 pi means landing at the same direction on a circle. After the full macro cycle, theta 10 equals theta 0 plus the sum of all 10 phase increments. The closure condition says that this sum is congruent to 0 modulo 2 pi, so theta 10 is congruent to theta 0 modulo 2 pi. The final conclusion is that the process increases the scalar quantity b while the phase returns to its starting direction after one complete cycle.